Welcome to the Adirondack Sky Center and Observatory. There's nothing more inspiring than the night skies in the Adirondacks. It just makes sense to start your visit to the wilderness above with us. Our current programs focus on immersive experiences for audiences of all ages. They reach as close as into our own community and as far away as students from around the globe. From inspiring presentations given by some of our friends as world experts, to our Keystone 4-day astrophotography conference, there's something for everyone, including live as well as virtual stargazing, customized programs for schools, and private events. In the case of the Adirondack Sky Center and Observatory, the sky is certainly not the limit, but only the beginning. A second building is currently in the planning stages in the form of an Astro Science Center and Planetarium. This 18,000 square foot building will be dedicated to the study of astronomy and space travel. The planned $15 million Astro Science Center will feature a state-of-the-art planetarium under a 30-foot dome, a 100-seat theater, and a large area for hands-on and interactive activities. Our many exhibits will include a Foucault pendulum, overhead models of the solar system, and historical permanent as well as traveling collections. It's our mission to make this an immersive experience for everyone. You will never be told to look and don't touch. This new building will be in addition to our existing roll-off roof observatory, which houses 4 permanently mounted telescopes. The final phase of construction includes a traditional observatory dome housing a new 22-inch research-grade telescope. Please contact us to become a member or make a donation to help build this new Astro Science Center and Planetarium and begin your journey to the wilderness above. Hope you're inspired to begin our Orion series of talks tonight. I want to ask everybody to mute your microphones if they're not already muted. During tonight's presentation, we'll have some Q&A after the presentation itself, and the presentation will be available, as always, on our YouTube channel within a day or two. So I'd like to introduce Robert Naeye. He's an award-winning freelance journalist and former editor-in-chief of Sky and Telescope and Mercury magazine. He's authored 2 books and contributed to 3 others, including NASA's official 50th anniversary volume. Bob has given more than 100 lectures all over the world, mostly about astronomy. Authored many hundreds of articles on astronomy and other topics, and edited many hundreds of others. He also worked for NASA for 16 months at its Goddard Space Flight Center in Greenbelt, Maryland. He currently lives just outside of Hershey, Pennsylvania, the town where he grew up. And now from an undisclosed location there in Pennsylvania, please join me in welcoming Bob Naeye. Bob, it's all yours.
Okay, great. Thank you. I'm going to do my screen share, and this should work. Are we good?
We are good.
Okay, everybody can hear me okay and see my screen here?
Yes, we can.
Okay, great. So I'm going to get started. First of all, I want to thank Seth McGowan and Carol Levy for inviting me and setting up tonight's Zoom meeting. And I want to especially thank the Adirondack Sky Center for organizing this Orion lecture series and allowing me to be part of it, which I really appreciate. And most of all, I just want to thank all of you for Zooming in tonight. It's a great pleasure to be with all of you. So I'm going to be discussing tonight whether or not we have picked up a radio signal from an extraterrestrial civilization. And making this even more interesting is that this signal is coming from the direction of the nearest star to the sun, a star called Proxima Centauri. So this story has gained a lot of traction on the internet. I wrote a news story about it for Astronomy Magazine's website, and it's been in other publications as well. Now, I want to stress right off the bat that this signal is probably not from ET. But if we have picked up a signal from ET, it raises a set of very profound questions about whether and how we should respond and what humanity's place is in the universe. So even if this signal, as in all likelihood, turns out to be man-made interference, we're still going to face many of the same questions about how we should try to communicate our civilization to the stars and possible other civilizations. I want to stress also at the outset, the Discovery team has provided very little information about the signal. They haven't published any papers. They haven't put any information on the website. They haven't done any press releases. So I'm just kind of going by what they've said to various media outlets like the New York Times. So I don't know a lot more than what I'm going to be telling you tonight. Nobody other than the team knows much about what's going on, but still I'll be happy to take questions during the Q&A, but I'm also hoping that my comments later on can get some of you to maybe think and offer your thoughts after my presentation ends. So the discovery was made by the most advanced SETI project in the world, which is called Breakthrough Listen. Now, if you haven't heard the term SETI, it stands for Search for Extraterrestrial Intelligence. So SETI's been going on since the early 1960s, but mainly at a fairly low level. It's not something that gets a lot of funding. The main avenue that astronomers are looking for other civilizations is using radio. And it's pretty simple why, and that is radio waves. It doesn't take a lot of energy or resources to produce very, very powerful radio signals that could be detected at great distances across the galaxy. The radio waves travel at the speed of light, so they're the fastest type of signal we know about. And also that, artificial signal can be crafted and transmitted in such a way so that it'll be easily distinguished from a natural radio source like a galaxy or a star. So we see this tech billionaire at the upper left, Yuri Milner, and he's funding a lot of this project. Back in 2015, he gave Breakthrough Listen $100 million to get going. Now, the two main radio telescopes that this project use, one is in West Virginia. We see on the left the Green Bank telescope. And the one I'll be really talking about tonight is the Parkes Observatory in New South Wales, Australia. Now, even though they are doing SETI, most of the time, they're just doing routine astronomical observations, but their receivers can decipher like millions of different channels. So SETI is kind of piggybacking on the routine astronomical observations. So this is the 64-meter wide Parkes telescope in Australia, and it picked up this signal that I'll be talking about tonight on April 29th, 2019. So what was happening is that this telescope was observing this star, Proxima Centauri, and it was not trying to detect ET signals. It was listening for radio emission from very powerful flares being shot off the star, which gives off radio waves. But what's interesting is about 6 months ago, an intern with this project discovered that embedded in this radio emission from the flares, there was a fairly weak narrowband signal and what makes it really interesting is that this signal, when the telescope was pointed at Proxima Centauri, it picked up this signal, but then the telescope would point away from the star and the signal would go away. And this happened 5 times. So the team then ran this signal, this narrowband signal, through various algorithms that are intended to filter out sources of human radio interference from things like satellites, interplanetary spacecraft, and even ground-based sources such as airplanes, automobiles, and even microwave ovens. So this signal survived every one of these filters. So the team dubbed it Breakthrough Listen Candidate 1, or I'll be referring to it as BLC1. And by the way, I show on the right the movie The Dish, really funny Australian comedy about how this Parkes radio telescope was used to relay the radio transmission from Neil Armstrong and Buzz Aldrin during the first Apollo 11 moonwalk. So if you haven't seen this movie, it's a comedy. It's not really factually accurate, but it's a great, wonderful movie, and it's based on a true story. So this finding that I was talking about was not intended for public consumption, at least not yet. But someone on the team or someone leaked the story about this detection to the British newspaper, The Guardian, who broke the story. You can see here their website from February 18th of 2020. So articles have since appeared in Scientific American, National Geographic, the New York Times, The Atlantic, and many other publications and websites. But as I mentioned a minute ago, the team has not published a paper. There's no information on the website. So the team's kind of gone silent. They're apparently working on 2 papers for the scientific journal, but I don't know when they'll be published. So the team right now is kind of in analysis mode and not talk to the media mode. So the signal itself was apparently very narrow in bandwidth, and that's really, really important. This is not the actual signal, by the way. This is just showing how a narrow band signal differs from a broadband signal. The left axis, vertical axis, is strength of signal, and the right is the frequency. And what really is interesting is that humans, we prefer to transmit narrow band signals for obvious reasons, because it's more efficient to pack all the energy of a radio transmission into a very narrow range of frequencies. And then a narrowband signal stands out against all the background noise. So that's why when you tune a car radio trying to pick up your favorite station, you have to get it very precisely to pick the station. If you're a little bit left or right of the station, you're not going to catch your music or news or whatever. But the thing with Mother Nature, and this is what's really important, is that Mother Nature doesn't care about efficiency. She spreads her radio signals across a broad range of frequencies. So as a result, there are no known natural radio sources that produce narrowband signals. So these SETI projects like Breakthrough Listen are specifically looking for narrowband signals because they strongly indicate an artificial origin. Okay, this also is not the actual signal, but it shows that the team told the media that when they were detecting this signal, it was gradually drifting toward higher and higher frequencies, as we see here. But they didn't say by how much. Now, there's a couple things that could cause this. The most obvious would be a source that's moving toward the Parkes radio telescope, creating a Doppler shift, just like an ambulance. As it gets close, as it's approaching you, it gets higher and higher in frequency. Let's say it was an airplane approaching Parkes. The signal, if it was being transmitted at a constant frequency, from Parkes's point of view, it would be Doppler shifted to a higher frequency. Now, and as I'll be talking about in a few minutes, there is an inner planet orbiting Proxima Centauri in the star's habitable zone. But at the time that we were detecting this signal, that planet was actually moving away from Earth. So the pitch should have, the frequency should have gone down, not up. But if the signal has an artificial origin, who's ever transmitting it might be purposefully changing the frequency as they were transmitting the signal. So the fact that we can't say for certain it comes from this planet doesn't rule out the possibility that it came from that planet. Now, the wavelength that this signal was detected, you can see my red arrow at the bottom. It was detected at a frequency of 982.02 megahertz. That's 982.02 million cycles per second. And that's just outside a region of radio frequencies that radio astronomers like to do SETI. They call it the water hole because that's the bandwidth emitted by interstellar hydrogen H and hydroxyl OH, which are the two compounds that combine to form water. So of course on Earth we might, like in the Kalahari Desert of Africa, the animals meet around the water hole. It's been long thought that maybe extraterrestrial civilizations send signals in the water hole, especially because we think water is a very important substance for life. And what also makes this an interesting frequency is that this is a part of the radio spectrum that is not frequently used by humans, and especially our spacecraft. So humans can certainly transmit at 982 megahertz, but we generally don't. The one thing that argues against it being ET, though, is you'll see it's very close to an integer value, 982.02 megahertz. And that argues against it being an alien signal, because why would they, use our unit of measurement to, send it right at an even integer and a human unit of measurement? They have, they would have their own units of measurement. So it doesn't rule it out, but I think it makes it less likely to be an ET civilization. The signal was apparently monotone in nature, meaning it was a very simple carrier wave like the one at the top here. In other words, it wasn't like the middle and bottom waves, which you can see are modulated amplitude or frequency to give us AM and FM radio. When you modulate a radio wave, you can carry complex information like music or a radio talk show host, for example. Well, this signal was not modulated. So it was a very simple signal, not really intended to convey any real information. I just also want to mention that, it appears to come from the direction of Proxima Centauri. It is possible that it came from an even more distant source, and that Proxima Centauri just happened to be like in alignment. But in all likelihood, I mean, the telescope was centered on Proxima Centauri. It's only, as I'll mention in a minute, only about 4 light years away. So in all likelihood, if this thing did not come from an Earth or born source, or, like a satellite or spacecraft, this probably came from Proxima Centauri. So because BLC1 was a narrow bandwidth signal, and the fact that it appeared when the telescope was pointing at the star and not when it was turned away, it's probably the best SETI candidate signal since the Ohio State Big Ear Radio Telescope, which you can see at the lower right, picked up the famous WOW signal on August 15th, 1977. So the WOW signal got its name from the astronomer's handwritten notes, which you can see at the left on this computer printout that was recording the strength of signal during the observation. And the signal was so powerful, it went into the letters of the alphabet. You can see a graph on the right. This was a very, very powerful narrowband signal coming from the direction of Sagittarius, although the precise coordinates are unknown. What's interesting is that there were no known satellites or spacecraft in the general direction of where this signal was coming from. The signal lasted at least 72 seconds as, Earth rotated and it passed over the radio observatory. The problem is this signal's never been observed to repeat, so its origin remains unknown. And my guess is we will never know what produced this signal. But what we can say is that this signal has all the hallmarks of the kind of signal we would expect from another civilization. Sadly, however, that wonderful radio observatory, Big Ear, was torn down in, let's see, what year, 1998, to make way for a golf course. So is BLC1, is it an ET calling card? Have we detected a signal from another civilization? Well, the executive director of Breakthrough Listen, Pete Worden, has said that there's a 99.9% chance it was radio interference. And you can see from his tweets here, which were sent a day after the Guardian story came out, that, the team's official, line is, we think this is just radio interference from some human source, and we haven't pinned down the source yet. But, my guess is that's what they truly believe. But, until the team completes its analysis, which they haven't done yet, it has a very strong incentive to be very cautious in any statements they make to the media or public. But, there have been other signals that have been picked up that have some of these characteristics, and they've turned out to be interference. So my guess is that we're going to know fairly soon, one way or the other, hopefully in the next few weeks or months. So I want to just shift gears now and turn to the star Proxima Centauri, whose location is arrowed by that red arrow toward the lower left. Now, the star is in the southern constellation of Centaurus, meaning we can't see it from the northeastern United States. Now, my friend Julio, who's in Lima, Peru right now, is listening in tonight. People in Peru and in the southern hemisphere can see it, but you can't see it with the naked eye. This star is 11th magnitude, which means it's about 100 times too faint to be seen with the naked eye. But you can at least see its position here arrowed on the map. And you can see to the upper left, you can see the Greek alpha symbol followed by CEN. That's the star Alpha Centauri, which I'll be getting to in just a minute. So here's a chart showing the sun's nearest stellar neighbors. Now, this map is a little bit misleading because the stars are in different directions and space is three-dimensional. But you can see here that Proxima Centauri, kind of a little bit to the right, is very close to the sun or the solar system. It's only about 4.25 light years away. And you can see it's very close to Alpha Centauri A and B, which are just a little bit farther away at 4.37 light years. Now, remember that a light year is the distance that light travels in 1 year. So that's about 6 trillion miles. That's a 6 followed by 12 zeros. So that's an enormous distance by human standards. That's about 25 trillion miles. But by galactic standards, that is very, very close. And it's interesting is that all the stars are moving as they orbit the center of our galaxy, and Proxima Centauri, along with Alpha Centauri A and B, drifted into the sun's vicinity right around the time that Homo sapiens, our species, arose on Earth. So I want to just show you, compare these stars here. Proxima Centauri is the smallest member of what's called the Alpha Centauri triple star system. And what I mean by a triple star system is the system consists of 3 stars that are gravitationally bound to one another. So here you can see the 3 stars compared in size and color to the sun. Now, Alpha Centauri A, you can see it's a little bit bigger. It's a little more massive, a little bit hotter than the sun. Alpha Centauri B is a little smaller and cooler. That's why it's more orangish, a little bit less massive than the sun. And you can see Proxima Centauri is the pipsqueak of the system. It's by far the coolest, smallest, and least massive and least luminous of the 3 stars in this triple star system. And this shows how the system is configured. Now, on the scale of this map, A and B are shown by just 1 star. They orbit each other at roughly the same distance that Earth or that Uranus orbits the sun, about 20 times the distance that Earth orbits the sun. And they take about 80 years to complete an orbit. They're basically orbiting around a common center of gravity. But you can see here that Proxima is way far out from A and B. It's about 400 times farther from A and B than A and B are from each other. And it takes Proxima about 500,000 years to orbit the Alpha Centauri A and B binary system at the center of the system. The system as a whole is about 5 to 6 billion years old. So it's a little bit older than the sun. And what makes that interesting is that's plenty of time for life to get going and evolve into, something intelligent. So here we see Proxima Centauri compared to objects in our solar system. And you can see it's really wimpy compared to the sun. Its mass is only about 12% the mass of the sun, and its total energy output is less than 1% of the sun's. And you can see here that it's only about twice the diameter of Jupiter or Saturn. And it's about 5,000 degrees cooler than the sun, which is why it appears reddish. So it belongs to a class of stars called red dwarfs, which are really wimpy stars, but they actually comprise about 3/4 of all the stars in our Milky Way galaxy. Okay, but despite the fact this is a really small and feeble star, there's a lot of excitement about it even before this radio signal. And that's because in 2016, European astronomers discovered that it has a planet known as Proxima Centauri b. So this is a speculative artist rendition of the system. You can see Proxima Centauri is the orangest star to the upper left. The planets in the foreground at the right, the big ball at the right. And in between, you see those two little white points. That's Alpha Centauri A and B in the far distance. So astronomers discovered this planet using what's called the radial velocity method, which measures how a planet's gravity is tugging upon its host star. So this method has been used to find hundreds and hundreds of planets orbiting other stars, but it doesn't tell us anything about the planet's physical characteristics other than its minimum mass. And the planet does not pass in front of the star as we see it from Earth, so we can't see it blocking the star, so we can measure its diameter by how much starlight it blocks. So all we really know about this planet is that it's about 17% more massive than Earth. So it's probably just a little bit bigger and more massive than our planet, probably has a little bit stronger surface gravity. It would be hard for an NBA player to dunk a basketball on this planet. It's probably mostly rocky, and it probably falls into a category of planets known as super Earths. Now, this shows its orbit. I don't know if some of you are blocked. If the right part of your screen is blocked out, it shows the orbit of Mercury around the sun compared to the orbit of this planet B around Proxima Centauri. Well, what you can see here is it orbits really, really close to the star, about 1/20th the distance that Earth orbits the sun, and it goes around the star every 11.2 days. So a year on Proxima Centauri b would be only 11.2 Earth days. And I really want to stress, we have no idea if this planet has an atmosphere, a magnetic field, volcanoes, oceans, moons. We know almost nothing about this planet. But I did want to show you this as some humor. This cartoon, we see Proxima Centauri at the left bragging that it has a planet. Way to go, Proxima. We do not know if the two bigger stars in the system, A and B, at the upper right, have planets. We haven't found any, but we haven't, you can't rule out the possibility that they have planets, but we know that Proxima has a planet. And better yet, that planet orbits in the star's habitable zone. And that's really interesting. It means that this planet is receiving about the same amount of energy that Earth receives from the sun, meaning it can have liquid water on the surface, also meaning that it could possibly support life of the kind that we have here on Earth. The one downside, being so close to the star's gravity is almost certainly tidally locks the planet, so it revolves at the same rate that it rotates, just as the moon does to Earth. We only see the near side of the moon. Well, if you're on this, looking at it from the star, you would only see one hemisphere of this planet. So it's close to the star. So one hemisphere is getting heated, the other and could be very hot. The other hemisphere that faces away from the star is probably very, very cold. But if the planet has a thick atmosphere and strong winds, those winds could redistribute the heat and make much of this planet's surface habitable. We just don't know. This is, you can see, this is the background I'm using behind me. This is a beautiful piece of space art depicting Proxima Centauri B's surface, but nobody really knows what it looks like. But, this is a good educated guess. We can kind of see the star, Proxima Centauri, excuse me, kind of at the upper left, obscured by clouds. And then Alpha Centauri A and B are at the upper right. They'd actually be closer together in the sky and fainter, but it's still a beautiful artist rendition. So if you're wondering, is this planet habitable? The only honest answer is we don't know. Now, one argument against it being habitable, this is another artist rendition, is, as I mentioned at the beginning of this talk, this star produces very powerful flares, even more powerful than the flares that the sun produces. Now, this planet is really close in, so it's getting bombarded by these powerful flares. Would these flares strip away its atmosphere? Or, due to the flares which bombard it with X-rays, ultraviolet radiation, high energy charged particles? We just don't know. If the planet, let's say, has a lot of volcanism, it might continually replenish its atmosphere. It might have a strong, very strong magnetic field, which would help protect the planet. So we just don't know whether these flares would be a showstopper for advanced life. We just don't know. And then making the system even more interesting is, just a few years ago, astronomers discovered that it has a second planet called Proxima Centauri C. You can see it here on the right. This artist rendition is making it look like kind of a miniature version of Neptune. You can see B, the planet, that crescent to the left, and the star at the lower left. We don't know much about this planet other than it has at least 7 times the mass of Earth, and it orbits the star every 5.3 years at about the same distance that Mars orbits the sun. So I think this is a very plausible artist rendition. It's probably too cold to support life as we know it, but who knows? And we don't know if Proxima Centauri has additional planets that we just haven't discovered yet. So getting back to the BLC-1, this signal, how can we tell if it's coming from ET? Well, the Breakthrough Listen team is undoubtedly listening to this star with the Parkes Observatory to see if the signal repeats. And one thing they've already announced they're going to do is, on April 29th of this year, that's the 2-year anniversary of when they detected this signal, they're going to repeat the exact sequence of observations to see if they can detect this signal. I have no doubt the team is looking at archival data from this telescope when it was pointed at Proxima to see if earlier observations picked this up. And they're undoubtedly trying to track down every conceivable source of interference. In fact, something as mundane as like the microwave oven in the visitor center. And the other thing I'm sure they're doing as well is they're trying to observe this star from other radio telescopes in the southern hemisphere. Here's one of the better ones called the Meerkat Array in South Africa. Unfortunately, because this star is fairly far south, we can't observe it from most of the big radio telescopes in the northern hemisphere. But as I said earlier, I'm expecting we're going to have an answer in a few months. If the team can identify the source of interference, this idea that it might be an ET signal will die a very quick death. But let's say they find the signal again and it repeats, or maybe they start detecting it at different frequencies. and they detect it at different observatories, and they can rule out that it's any kind of ground-based signal. There's no known spacecraft in that direction. Then Breakthrough Listen will have made what I think will be the greatest scientific discovery in history. And that would be a radio transmitting civilization only 4.25 light years from Earth, at the nearest star to the sun. Now, some astronomers have come out and said that how likely is it that the nearest civilization would also be at the nearest star? And they said that is so unlikely that we can rule out this being an ET signal. But Jason Wright, who's a really brilliant astronomer, right not far from where I live at Penn State University, he's pointed out that that is not a very good argument. So for example, like let's say I'm calling Seth McGowan on my cell phone. My signal doesn't go directly to him. It goes to a cell tower, and then another tower, and then another tower, and eventually a tower sends it to Seth's cell phone. So that we could have a situation where the Milky Way galaxy has this intergalactic communication network set up by one or more advanced civilizations. So maybe, you know, they know that there's this emerging civilization in the solar system. They would set up a radio transmitter at the nearest star to send and receive signals from Earth. So in that case, we would only expect to receive ET radio signals from maybe the nearest star or the nearest handful of stars. So if Jason's idea is correct, you know, then it's not surprising that this signal was detected from the direction of the nearest star. So for the sake of fun, because if this is a signal from like an airplane or, you know, an automobile, then I could finish the talk right now. But let's just assume that it is a signal from an extraterrestrial signal. That's the more fun and interesting interpretation. So then the questions, and these are really interesting questions. What should we do next? Should humanity respond? Who should decide how to respond? And if we do respond, how should we respond? And what, you know, who are they? Who are we communicating with? What are their motives? Do they pose a threat to us? And what, if anything, do they already know about us? And who speaks for Earth? You know, these are huge questions, and the answers are far from obvious. But if this is an ET signal, you know, this is, you know, think about this. We can send a signal easily within our current technological ability to send a powerful radio signal to this star that any civilization there would be able to detect. It would take our signal 4.25 years to get there. They could pick up the signal and reply. So about 9 years after we send our signal, we could get a reply. And I bet you almost everybody in on this Zoom session will still be alive 9 years from now. So, I mean, imagine how exciting it would be to get a radio signal from another civilization responding to our, you know, to our radio signal. And believe it or not, you know, scientists, philosophers, linguists, and other influential thinkers have really given serious thought to the concept of METI. That's short for messaging extraterrestrial intelligence. So until this Proxima signal, though, astronomers were assuming that if we ever got a signal from another civilization, that signal would be hundreds or thousands or, you know, tens of thousands of light years away. So they would be at a safe distance, but it would make interstellar communication very frustrating because it could take centuries or thousands of years to really have a two-way conversation. And of course, that's very dissatisfying. But having another civilization only 4.25 light years away would be a game changer and would add urgency to these questions. Now, some of you might be wondering, have we already sent out radio signals? And the answer is yes, but only at a very rudimentary level. So in 1974, radio astronomer Frank Drake, who you can see at the upper left, use the Arecibo telescope in Puerto Rico, which has just been decommissioned, by the way, to beam this message at the far right in the direction of a very dense star cluster, a globular cluster, which you can see at the lower left, called M13. Now, this cluster is 25,000 light years away, so it's going to take our signal 25,000 years to get there. If there's any civilizations in this cluster that pick up the signal, it would take their signal another 25,000 years to get back to us. So we won't receive a reply for 50,000 years. And I don't know about any of you, but I don't expect to be alive 50,000 years from now. Now, the message he sent was coded in binary, essentially zeros and ones, arranged in a set 73 rows and 23 columns, both of which are prime numbers. So if another civilization picks up this stream of zeros and ones and they can figure this out, the message encodes information, about our, the solar system and Earth's place in the solar system, our biochemistry, the nature of the radio telescope. It actually conveys a fair amount of information. The signal, by the way, by the time it gets to the star cluster, will be unbelievably weak after traveling 25,000 light years. So this is really more of a proof of concept than a really serious attempt to signal other civilizations. There have been other METI attempts since, mostly privately funded efforts that beam radio signals toward nearby stars. And in case you're wondering, the most powerful radio signals we're sending out right now are from this line called the North Warning System, kind of this pink line across the top north part of Alaska and Canada. And these are powerful radio signals that the US military sends out to detect incoming ICBM missiles, carrying nuclear weapons from Russia. And these radio signals could be detected by another civilization out to a distance of about 10 to 20 light years. So, sending a detectable radio signal to Proxima Centauri, basically involves hooking up a powerful radio transmitter to a large radio antenna. And that is something that is well within the means of pretty much every nation state in the world, or even wealthy private organizations and individuals. But as I asked a few minutes ago, who speaks for Earth? Any message we send out, it's not even just a message from humanity. We also have a responsibility to all the other life forms with whom we share our planet. And I would think and hope that any decision to respond to a genuine ET signal would be discussed at the United Nations, and that people and nations from all over the world with different cultures have a chance, to voice their opinions. I mean, the problem is we're never going to get unanimous agreement. After all, people in our own country can't even agree on whether or not to wear a facial mask during a pandemic. Now, I think we should set the bar very, very high, meaning we should not send a signal unless like a very high percentage, like a super duper majority of nations representing the large majority of the world's population agree to send a signal. That's how I would do it. Another thing we have to worry about, though, is someone going rogue. Some multi-millionaire tycoon sets up a telescope in Australia and starts sending out radio signals without permission from any organization. That would be something we'd have to look out for. And before responding, and I bet you all of you would agree with this, I think we should first try to learn everything we possibly can about who these creatures are at Proxima Centauri. So for example, this is a very sophisticated ground-based telescope that's being planned that could give us detailed study, allow us to get detailed observations of stars up to several dozen light years from the sun. So this could give us very detailed observations of all the planets orbiting Proxima Centauri. We could also build really even better space telescopes than the Hubble Space Telescope and the James Webb Space Telescope, which is scheduled to launch this autumn. Another thing we could do is build a giant radio telescope on the far side of the moon, just using a crater and to pick up radio signals. And this would be this is the best place in the solar system to do SETI, radio SETI, because it's shielded from all the radio traffic from Earth. So something like this could really allow us to detect, very faint radio signals coming from Proxima Centauri. Now, and this is a really important point to understand, that it's incredibly improbable that humanity and any civilization at Proxima Centauri would reach the same level of technology simultaneously. So we have to assume that their civilization is more technologically advanced and probably a lot more advanced. They probably have astronomical technology that has already discovered Earth maybe thousands of years ago, or millions of years, probably thousands of years ago. And they've taken the spectrum of our planet's atmosphere. This is something we'll be able to do in the coming decades. And as shown here, their spectral data of Earth would reveal the presence of water vapor, oxygen in the atmosphere in the form of ozone, or O3. That's 3 oxygen atoms combining into an ozone molecule, and carbon dioxide. They would conclude from this spectrum that there's probably life on the third planet from the sun. And it's even conceivable that they already are aware that there's a technological civilization here on Earth. Maybe that's why, if this is a genuine ET signal, they're sending signals our way to catch our attention, and might be their way of saying, let's start a conversation. It's possible that they're even monitoring our progress and know quite a bit about us. And one thing that we don't know about them, we don't know if they're biological or whether they're like machine intelligence running on artificial intelligence. So the late British physicist Stephen Hawking once said, quote, "Meeting an advanced civilization would be like Native Americans encountering Columbus. That didn't turn out so well." He also said that, quote, "Super advanced civilizations could be rapacious marauders roaming the cosmos in search of resources to plunder and planets to conquer and colonize. And for good measure," he said, "they will be vastly more powerful and may not see us as any more valuable than we see bacteria." That's a bit humbling. But to counter that, Carl Sagan argued in his Cosmos television series that it's possible that advanced civilizations are highly enlightened and ethical and confident in their own survival. After all, they managed to survive their own technological adolescence. So I would agree with Sagan. It would be wrong or mistaken to just assume that they're hostile. They could potentially help humanity by giving us information about how to cope with our various struggles, like climate change and violent tendencies. So if there's a civilization at Proxima Centauri, I don't think we can assume they're friendly or they're hostile, or they might be completely indifferent to our existence. And I love this art here. If they are hostile and far more advanced, then Hawking is right in the sense we could be in grave danger. Now, you've seen sci-fi movies where the aliens attack and we fight back and defeat the aliens. Well, that is totally unrealistic. If they want to get rid of us, they will get rid of us. There's a whole bunch of ways they could do it, and we would have no defense whatsoever, at least not for hundreds or thousands of years into the future. They could, for example, take an object smaller than an automobile, accelerate it to 99% the speed of light, and put it on a collision course with Earth. This is what would happen. The energy would be so enormous that it would basically sterilize Earth. It would be catastrophic. They could take, the other thing they could do is take an asteroid, kind of a medium-sized asteroid, divert it, and slam it into Earth at a slower velocity, basically repeating the extinction that wiped out the dinosaurs 66 million years ago. Another thing they could do is genetically engineer a deadly pathogen that, unlike the coronavirus, is like 1% mortality, is 100% mortality, and something that would spread very quickly. And very quickly, they could eradicate humanity and perhaps preserve the rest of the biosphere. So, but I tend to think that despite these nightmare scenarios, why do they have any reason to attack us? We don't, at our level of technology right now, we don't pose a threat to them. So I think it is very unlikely. I mean, I don't spend any time at night worrying about aliens attacking us. I worry a lot more about what we might do to ourselves, like nuclear war, environmental destruction, etc. And I want to conclude the final couple minutes. I want to discuss how this star's close proximity makes it much easier to envision interstellar travel. So the parent organization of Breakthrough Listen is called Breakthrough Initiatives, also funded by Yuri Milner. So for several years now, they have been planning an interstellar mission to Proxima Centauri, even before this radio signal was picked up. They call it Breakthrough Starshot. And the idea is you make about 1,000 tiny little spacecraft called nano spacecraft. You attach them to light sails, and then you use very powerful lasers to the momentum of the photons in the laser push against the sail and can accelerate these light sails to about 20 or 30% the speed of light, which means it would take these nano spacecraft only a few decades to get to Proxima Centauri. So here we see a design for these nano spacecraft. Now, if you send 1,000 of them, even if like 990 of them fail, 10 will get to Proxima Centauri, collect data, and presumably send data back to Earth. So you could argue if there's a civilization there, that would add urgency to this, to try to get data from the system itself, in less than 100 years. But you could also argue that we shouldn't do it because what if you're this civilization at Proxima Centauri and suddenly you see these light sails zooming through your system coming from the direction of one of your nearest stellar neighbors, and there's a planet there that has life? You might interpret this as a hostile, aggressive move. So I don't know if we should send this mission or not. If there doesn't appear to be intelligent life there, then by all means we should, send this mission. But, think about it. We've only been flying powered aircraft in our atmosphere for only about 120 years. And we're already contemplating an interstellar mission to Proxima Centauri. So, our species is making remarkably fast technological progress. And I think it strongly suggests that interstellar travel is possible, especially between, two planetary systems that are less than 5 years apart. And I just want to conclude by saying, if I had to wager a lot of money, I would definitely bet that BLC1, this radio signal, will indeed turn out to be human radio interference. We will probably know soon, hopefully within a few months, but in the slight chance that it's a real ET signal, humanity is going to face some very interesting and important decisions. And this will take over, at least for a short period of time, everything else that's driving the news cycle. This will be a worldwide global headlines, and there will be intense discussion about all of this. But even if it's not an ET signal, even if BLC1 is just interference, it still raises questions about how we would respond to an alien signal, and should we be intentionally broadcasting our presence using radio out into the galaxy? And if so, what should we say? And what do we want aliens to know about us and our planet? So it forces us to think about ourselves in a broader cosmic context. So I don't claim I don't claim to have any special insights or opinions on these questions. So, besides questions, I'd be interested to find out what some of you think about these issues. And I'll just close by thanking you all for tuning in tonight. And if you're interested in reading more about this topic, these are 3 recent books that I very highly recommend. The left book is by an American author. He's a contributing editor to Sky and Telescope magazine. The 2 books on the right are written by British authors, but they're all really, really good books. Thank you all very much.
Thanks, Bob. We do have a couple of questions hanging out there, so why don't we get to a few of those?
Yeah, absolutely.
Richard Griguski, you had one earlier. It may have been answered. You'd like to unmute and ask your question from earlier?
Basically, I wanted to ask about how long ago did this signal originate from this Proxima Centauri area?
Okay, well, good question. It was detected in April 2019, so it would have been emitted from Proxima 4.25 years before that. So like late 2014, early 20, I'd have to do the math, but late 2014. So, I mean, it was emitted, if it was from Proxima Centauri, it was emitted while everybody in the Zoom call was very much alive and, an adult. So, I mean, that tells you how close this star is. I mean, it was emitted less than a decade ago.
Thank you.
And I think you also said that if we were to send a signal there, it would be, 4.25 years there, and then an answer and a 4.25 back. So it'd be about 9 years until we heard something back.
Yeah, exactly. Exactly. It'd be about 8.5, 9 years. So that's less than a decade. And that's what's really exciting about this, if it's real, because we can have like a real conversation. I mean, we could start sending information or, all sorts of information using binary code. We'd have to try to first establish a common language, probably using mathematics, because that would be a language we have in common. But over time, I mean, we could establish some kind of understanding and communicate, really in-depth information about ourselves, about our planet, about our planetary system, and presumably, they could do the same thing. So that's what makes this like really, really interesting, is the ability to have a real conversation with another civilization. Once again, I mean, SETI has long assumed if we ever pick up a radio signal, the closest might be a couple hundred light years away. So, you can't really have a real conversation because we're sending signals and expecting a reply, not within the lifetime of the people who are sending the signal. Or within the people of anybody alive today. We're going to get a reply when there's a whole different group of people alive, a couple hundred years from now. But if the civilization is only 4.25 light years away, then suddenly, most people alive today would still be alive when we get a return signal. So that makes it like, wow, that would be really, really cool. But if they're hostile and they see us as a threat, then it becomes very dangerous. And so I hope I was able to convey that point.
Yes, in fact, I think the way you phrased it was that almost everyone on the Zoom call will be alive in 9 years from now.
That's right.
And I want you to be more specific. Is almost everyone on the Zoom call. Can you be more specific about who will be?
I wish I could. I mean, and I'll just, maybe I shouldn't say this, but I'm hoping everybody is either gotten vaccinated or is planning to get vaccinated. I'm not like in the top priority age group, so I'm still waiting my turn, but I do know friends, and my mother, for example, is 92, who've been vaccinated. And I've written a bunch of science articles about the vaccines, and they appear to be very, very effective and have the potential of ending the pandemic. So I'm hoping a lot of people get vaccinated, not just to protect themselves, but to help develop this herd immunity that can end the pandemic.
Bob, we've got one of our founding members of our organization right here in Tupper Lake, Mark Staves,
Oh, great.
On the call tonight, and he's got a question. Mark, are you there?
Yeah, I'm here. I just had to figure out where the unmute button was. Good to meet you, Bob.
Likewise.
My question would be, how likely would it be that there's a naturally occurring radio emission from this solar system, similar
Okay.
to that of the Jovian type radio emissions that we're all familiar with, or some of us are familiar with?
Okay, that's a great question. So we know that there's very powerful, we get, it's a fairly bright radio source because of the flares coming from the star itself. To my knowledge, we have not detected any natural radio emission from, the two planets. Certainly the outer of the two planets, could potentially be a radio source. Just as you said, Mark, that was a very good question. Jupiter is a radio source, but, Jupiter at the distance of 4 light years would be an extremely faint radio source. So it's possible we could detect natural radio sources from this star other than the flares. My guess is we'd need to do maybe that Far Side Lunar Telescope. But the thing that really makes this signal interesting is that it's narrow band. And, and I've checked with radio astronomers, we have never, ever discovered a really narrow band radio signal other than, artificial sources from humans. So if this is a natural source, it has to be of a new type of radio source that we've never discovered before. And even that in and of itself, to discover a new type of narrowband natural radio source, that would be itself a very important scientific discovery, although not as significant as like an ET signal. But it would still be a really interesting discovery, although it might be frustrating to the SETI astronomers because they always assume that if they pick up a narrowband radio signal, they're picking up an artificial source.
Okay, thank you.
Bridget wants to know if you would remind us the name of the movie that you recommended earlier.
Yeah, a great movie. It's just called The Dish, and it stars Sam Neill, who was made famous in the movie Jurassic Park. It's interesting because it's an Australian movie and he's a Kiwi. He's from New Zealand. And I want to make it clear, it's based on a true story about how the Parkes was used to relay Neil Armstrong and Buzz Aldrin's first moonwalk, their radio signals, because at the time, the United States, the way the Earth had rotated, we were faced away from the moon. So they used this radio telescope in Australia to relay the TV pictures of the moonwalk. There were high winds and they had to make a decision, like it was sort of above the threshold where normally they'd shut the radio telescope down. And they decided to go ahead. This was such a historically important moment to take a chance and relay the radio signals from the moon. That part of the story is true, but the producers of this movie build up very cleverly and creatively. They build up this whole story around it. And, that's basically a comedy. And, they kind of make fun of, they poke fun of themselves. They also poke fun at the Americans in a way that I find very clever, but not, it's not like they hate us or anything. They're just poking fun at us and poking fun at NASA, but they also poke fun at each other. The Aussies, I've been to Australia, and they have a very irreverent sense of humor. And it's a G movie, like there isn't like foul language or anything like that. So, it's a good family movie and it's just kind of a fun movie, but it's, once again, don't take it as an accurate depiction of the story. And I've been in the control room of Parkes and it looks like nothing like the control room that showed in the movie, but the movie does show the actual radio telescope, the real radio telescope. But it's just a fun movie. For those of you who haven't seen it, I highly recommend, buying the DVD or renting it or whatever. I've watched it many times and always get a laugh out of it.
Stuart Ward, are you still with us?
Yeah, I'm here.
Yep. Go ahead.
Hey, Bob, great topic and impressive, really intriguing presentation you gave.
Thank you.
I just have a kind of a silly question. I'm a little confused about one thing. If we're pointing our radio telescope right at Proxima Centauri, and I understand the planet may be fairly close, but if we're expecting a signal from a planet, not the star, how does that work? Like how is it that we can point it to a star but expect a signal from a planet that's not necessarily the same exact location?
Okay, great. Now I'm glad you asked me to clarify that. Thank you. The beam of the telescope it's about, I can't remember the exact angular size, but it's about half the diameter of the full moon. Now you have to remember that, Proxima is a long way away by human standards, and especially the inner planet is really, really close to the star. But even the outer known planet, they are both in the beam of that telescope. So any signal they're sending is going to be like from Parkes Radio Observatory's point of view, even if it's coming from the planet, it's going to be like coming from the star. In other words, the radio telescope is not resolving individual radio sources in the Proxima Centauri system. Like any planet that's orbiting Proxima Centauri that's sending radio signals toward Earth, the radio telescope's just going to all pick it up together. Now, I do want to mention, I showed you that let me go back a second, this ELF. If we were to build this of course is going to observe at optical and infrared wavelength, shorter wavelength, so there's more resolution, sharper resolution. This telescope would have a very complicated optical system to basically nullify the light of the star, so you can see the planet without being the planets being totally caught in the glare of the star. I think we're a long way away, or I'm not aware of any plans to try to do that with radio, but this is something to get really good information about the planet. You would have to resolve the planet as being separate from the star. But, astronomers are already working on the technology to be able to do that. Does that answer your question?
For sure. Thanks. That's great.
Josh Pratt, you had a question about technology? I don't know if Josh is still with us, but
I am. No, I'm here.
Yeah, great, Josh. Go ahead.
So my question was about the technology that would have to advance in order to make the conversation quicker. So 4 years there, 4 years back, what kind of technology would have to exist to speed that up?
Okay, very good question. Very good question. The problem is, the radio waves are traveling at the speed of light, because radio waves are basically a form of light, just a long wavelength form of light. So the radio waves are traveling at the fastest speed that we know of. So to speed the conversation up would require that Einstein's, theory of relativity is wrong, and there's some way to send faster than light signals. Now that violates, relativity. So in other words, that would violate the known laws of physics. So the question then becomes, is there some form of physics beyond which we already know? I would say most scientists would say probably not, but I wouldn't want to rule that out, and if there is faster than light travel or faster than light communication, then, radio is a very primitive form of communication. And, if the Proximans really want to communicate, they're using something more, much better than radio. But radio is a way you can do it. Radio is basically just a way that emerging technological civilizations like ours can communicate across interstellar distances, because the signals are inexpensive to produce. You can send a very powerful signal that you could detect on the other side of the galaxy without, breaking the bank. And, the signals travel at the speed of light. But if there's ways to communicate faster than the speed of light, then all bets are off.
David Bradford, are you still with us?
Yeah, I'm here.
Great.
Yeah, Bob, nice to listen to your talk. Got a comment and a question. The comment is relative to the Doppler shift of that signal. I think it should be quite telling because with the drift, that actually implies an acceleration, your source, not just relative motion between, but also then an acceleration. But if it's an intelligent life source, well, I mean, they can maybe it's just modulation on a very long time scale.
Yeah.
But anyway, so that's probably going to be a good clue for them to maybe figure out the source of it. The question is relative to those nanoprobes, the sails. How are they going to have enough power to send a signal back with any information that they might gather?
The great comment and a great question. What was I wanted to just say something about your comment. The one thing that the team has not released is how much signal drift they haven't announced how strong the signal was. They've said it's a relatively weak signal. They haven't announced how much it drifted in frequency, and they haven't announced like exactly how narrow the signal was. So they haven't published any of that data. So we don't really know like how much the signal drift was. As for the breakthrough initiatives, that those nano spacecraft, that's actually a question I have too. And I went on their website and I could not really find anything about how they would get a signal back to Earth with, little nanocraft that are like the size of computer chips. So that's something I don't understand myself yet. I will see. I'll try to maybe contact someone. Let me just write that down. And if I can get an answer, I will get back to Seth on that, because that's something I was wondering about as well. But when I went to their website, I didn't really see much information about that.
Yeah, and if you get an answer or any info, we'll be glad to post that on our right beneath the video for this presentation.
I mean, it's just and I should just mention, it's a really clever idea. It's a way to do an interstellar mission, to get a mission there to the star within like the lifetime of some of the people who launched the mission. And this is right now. There's been many other very ingenious ideas for interstellar travel. To make it interesting, you want to get your spaceship up to like 20 or 30% the speed of light, so you get there within a human lifetime. But all the other technologies that have been thought of are, possible in principle, and something maybe 100, 200 years from now we could do. But this star shot is the easiest way to do it, like in the near future. There's still a lot of technologies that have to be developed, like the power of the laser. This has to be an incredibly powerful laser. And, what kind of material do you use for the light sails? There's still technology we have to develop, but it's technology that seems to be kind of nearer term than some of the other ideas, like, antimatter engine, or like, hydrogen fusion engine or something like that. There's been a lot of clever ideas for how to power a starship, but this light sail technology is the one that we could probably do the quickest.
Great. Gene Vincent, are you with us?
I am.
Excellent.
Okay. A number of years ago, there was a project where individual citizens could sign up and use their own personal computers to participate in I think it was a SETI project.
Correct.
Whatever happened to it, and can individuals participate today? And if so, how?
And I actually, years ago when I was at Sky and or this is even back when I worked at Astronomy Magazine, we did an article on that. What was it called? It was SETI at Home. It was called SETI at Home, where they would parcel out chunks of data picked up by their radio telescope, send it to your computer over the internet, and it would run in the background. So your computer would sift through the data. And then if it found anything, would automatically, send it back, send that back to the SETI project. To my knowledge, I did read something, this was months ago, that it was shutting down, but I don't know. That's another thing. I'm going to look into that. I thought I remembered reading something, but if you just Google SETI and then the @ symbol, home, HOME, maybe you could find something. Once again, it's not just like there's one SETI project. There's different teams that do SETI. It's just that the Breakthrough Listen, they have like the most sophisticated receivers that can listen simultaneously to like 1 million narrowband radio channels simultaneously. But there are other teams out there that are trying to do radio SETI. And I also want to just mention too, and this is important, there are other ways to do SETI. I have my cover story in the September 2020 issue of Sky and Telescope talks about some of these other methods. And I've given talks about that are on the internet. There's a whole bunch of different ways you can do SETI besides listening for radio signals.
Thank you.
Yep.
SETI at home is on the Cal Berkeley website.
Yep. That's who was doing it like years ago. Because they were the ones that were kind of, for a while who were really running it. And they have a radio astronomer named Andrew Simeon, and he's sort of the radio astronomer head of the Breakthrough Listen project.
Yeah, their website says they're no longer distributing tasks.
Yeah,
So
that's what I remember reading. Okay, that's too bad, because that's a way to get the public, involved and excited. Well, the public's excited about it, but it's a way to get the public involved. And how would you like your personal computer to be the one that discovers an ET signal? That would be really, really cool.
yeah, I actually downloaded their software and I had it running in the background of my computer for some time.
Okay, but no ET, I guess.
No, not as far as I know.
Okay, but I assume it didn't do any harm to your computer or didn't slow you down or anything, right?
I was set up to run sort of in the background. So it was more like if you leave your computer on, you don't shut it off, then while it's sitting there, it would be chunking away. But then if you came back to your computer, it would tone back the activity from SETI. So it was sensitive to whether you were active or whether it was an idle computer.
Yeah, cool. Because I think, I was running it when I was an editor at Astronomy Magazine. I was running this, but that was so long ago that I kind of forgot what it was all about. I mean, I kind of remember you could look at like stuff going on your screen, but I didn't really know. I don't remember what that really signified.
Before it gets too late, I just want to post on the chat board for those of you that are tuned into that. And if you're not, take a look. This is some contact information for us, for the Adirondack Sky Center and Observatory. Our phone number, website, email, Facebook, and YouTube channel links are there. In particular, if you're interested in finding out more about membership, and even better, making a sizable donation, hopefully even, to our $15 million capital project, I hope that consider that, especially after such an interesting talk tonight. There is a specific website that I just linked also to make that donation right to through Bloomerang, which will allow you to make that donation right online. So that would be a great way to do it. Give us a call about membership, or if you want to find out more about our new building that we're working on, including a planetarium, that in addition to our existing roll-off roof observatory and future 22-inch research grade telescope.
Wow.
So very, very exciting stuff happening right here in Tupper Lake. We are the crossroads of the Adirondacks, and what that means is it's darker here than any place else. So you have the opportunity to come up and do some observing with us. That would be great once we're all released from the clutches of the pandemic. But in the meanwhile, certainly feel free to get involved with us by making any one of those contacts and hopefully helping us along the way with our capital project. Bob, thank you so much. What a great topic. Scared the pants out of me a little bit, to tell you the truth. Those pictures right there, that's what's going to keep me up at night. But great topic. And it sounds like you hit the wheelhouse for a bunch of people. I can see
Yeah.
some of our guests tonight. So that was really great. So thank you. And thanks everybody for joining us tonight. Look for future postings on our upcoming Orion series. We're going to try to do first week of the month for the next few months. We'll get a full lineup put up and posted so that you know in advance what you can look forward to right here from the Adirondack Sky Center and Observatory. Thanks, everybody. Have a great
Thank you,
night.
everyone.
Thanks, Seth.
Thank you.
The Adirondack Sky Center and Observatory. There's nothing more inspiring than the night skies in the Adirondacks. It just makes sense to start your visit to the wilderness above with us. Our current programs focus on immersive experiences for audiences of all ages. They reach as close as into our own community and as far away as students from around the globe. From inspiring presentations given by some of our friends as world experts to our Keystone 4-day astrophotography conference, there's something for everyone, including live as well as virtual stargazing, customized programs for schools, and private events. In the case of the Adirondack Sky Center and Observatory, the sky is certainly not the limit, but only the beginning. A second building is currently in the planning stages in the form of an Astro Science Center and Planetarium. This 18,000 square foot building will be dedicated to the study of astronomy and space travel. The planned $15 million Astro Science Center will feature a state-of-the-art planetarium under a 30-foot dome, a 100-seat theater, and a large area for hands-on and interactive activities. Our many exhibits will include a Foucault pendulum, overhead models of the solar system, and historical permanent as well as traveling collections. It's our mission to make this an immersive experience for everyone. You will never be told to look and don't touch. This new building will be in addition to our existing roll-off roof observatory, which houses 4 permanently mounted telescopes. The final phase of construction includes a traditional observatory dome housing a new 22-inch research-grade telescope. Please contact us to become a member or make a donation to help build this new Astro Science Center and Planetarium and begin your journey to the wilderness above.